So we are recording now, and I'm gonna do like a little introduction to what I was just saying. This workshop is designed for people with a wide range of experience, from everyone who might have experience to some language, but not precisely R, to people that use R every day, basically. The goals that we have here is mainly to learn about the tidyverse, which is an ecosystem of tools that work well together in R. But at the same time, and because it is so important for, in this case, for 2 Degrees investing initiative for our organization, it's so important that we collaborate with our analysis work. I also would like to use this workshop as an excuse to practice the entire workflow and the entire ecosystem of tools around R, which include Git and GitHub. And RStudio, which is an interface to all of that, and I'm going to show some images about that in a moment. So this little image here shows succinctly what the data science looks like. What are the tasks that we do when we do data science? Basically, we import the data. We sometimes need to restructure that data in some way that it's easier then to work with. And then we enter this kind of gray shaded area here that involves transforming the data in, for example, producing summaries and then visualizing it in a meaningful way so we understand what's going on. Maybe, producing some kind of model, maybe a linear regression or something like that. And once we are ready, we communicate our results in some kind of report. So the workshop is structured so that every lesson touches as many of these items as I could fit, so like every lesson is useful in itself, and it teaches you like real data science. The issue is that it's gonna grow, right? So the first lesson is gonna be a tiny data science project, the second lesson is gonna be a bigger one, and so on and so forth. And every time we'll use more tools and more complex approaches, and even different approaches, because one of the very important topics that Jakob suggested is to discuss the idea of iteration and how you can iterate at high levels of abstraction. Usually in programming languages, almost all programming languages, I guess every language has something equivalent to the for loop in R, and that's kind of the lowest level, at the lowest level at which you can create an iteration task. But we are going to learn that that's not the only way, and the tidyverse in particular offers a number of ways to iterate at higher levels so that you don't need to write the for loop yourself. Feel free to jump in, to drop as you like. Also, if you find that the lesson at the moment is too slow for you, you may want to just go ahead and do other things. I do appreciate that some people might have one camera on because it helps teaching, but if you want to do your work because this lesson is not very useful for you, it's totally fine if you just want to keep it on the background and do your thing. So in that case, yes, of course, turn off your camera and do your thing so that the rest of the people doesn't get distracted. So the idea is that we are going to proceed through the workshop in different lessons that each on itself is useful, it's fun, and moves you a little bit in the data science path. It's just that, in the beginning, we're going to be kind of writing, the analogy here is that we're going to be writing a skateboard, then we're going to, do something a bit more complex. So we're going to attach a handle, and we're going to be writing a scooter, and then we're going to attach bigger wheels and another bigger handle and a seat, and we're going to be writing a bike, then a motorbike, and then a car. So the different lessons have as a title those names: skateboard, scooter, bicycle, motorbike, and car. And that kind of gives you an idea of the complexity of the data science problem that we are tackling at the time. In terms of the logistics, because this video is also very intended to be consumed as a video, so this workshop is intended to be consumed as a recording after the fact. Most of the lessons are going to be we'll have some content, maybe a little theoretical, but then most of it is working. So I offer half of the screen real estate for you to follow along. We may have blocks where I just stop and you work, but in this setup, I think it's more useful, especially for those watching the video, for me to go relatively slow and type things from almost scratch or from degraded code, and for you to try following along. And then when we finish the lesson, any time that is left to the block of the lesson, you might continue to work on that lesson and asking questions with me on the background. So what I mean is that then I suggest that you use, for example, half of the screen for your own work, and at the background you might have the screen that I'm presenting on. So you will see on the background, me doing something, and then on the foreground to the left of it, you will see you will be working on your own work. So that's my suggestion. So for now, I'm going to expand this and keep moving. So the idea is for you to try to follow along, but that's fine if you get lost, because you can go back to the lessons later. Every lesson is also useful as an online document. I'm going to show that in a moment. If you want to ask for help, you can just say it here, unmute yourself and speak up. Because we are a private group, we can also use Slack, so feel free to type questions on the Slack channel. If we're working of a specific task, and one idea that I have, we might try it, is to just type the name of the task on the Slack channel tidyverse, and then start a thread about that task, and then to try focus questions about specific tasks, and keep each task as a comment, and then threads to those tasks. We'll see how it works. Maybe if I need to ask you if you are still working on finishing a task, maybe we use the thumbs up or down. And the general structure of each lesson is the following. I want to keep the structure as simple as possible and as predictable as possible for you to use your time in a predictable way. So every block's gonna have 50 minutes and then 10 minutes break. So it's not going to be so much around the content. I will try to fit content within the 50 minutes, but if we finish early, you may use the time all the way up to the hour. So the long story made short is that at every o'clock, you have that there's going to be a lesson starting, and try to be sharp. And every 10 to that you will have a break, so you can go make coffee, go to the bathroom, or do your whatever you're working on. So that's the goal. And if a lesson overflows, it overflows. That's fine. We will still force the break because our brains need to recharge, and then we come back and we continue from where we left. For the video, that's not a big problem because we can just edit the thing. But for us present here, I think that structure is key for you to know that you can use. You're gonna be free, for the last 10 minutes of the hour, and then you have a commitment on the top of the hour. So the very first lesson is starting now. It won't require you doing anything, the first half. And the second half is going to be about setup, and you may need to do setup depending on if you did it or not, or if you did it before or not. So the first half is a little touches on the theory, and the reason is not because it is crucial, because all of us already, or many of us, work with these tools even without understanding how they relate to each other. But one great thing of having the opportunity to sit here on a workshop is to kind of really expose the mental models that will hold the information in long term for us. So we actually teaching with Jackson before, we realized how much we learn of things that we were doing every day, but how much we learned when we had to articulate them in a formal way, and when we looked for slides and for images that would capture those concepts in a more permanent way in our brains. So the objectives of this first part is going to understand how each tool relates to each other. Also to understand what is this thing called the tidyverse that many of us already use every day, and many of us many of others have not heard about before. And what's its role in the typical data science workflow? What is the structure of tidy data? What do we mean when we say tidy data? It is an anticipation is that it is an arbitrary definition, but a definition that is very useful in the context of the tidyverse. What is the role of RStudio and Rmarkdown documents for data science? And an overview of the setup. That's going to be the second part, and that's the one that is hands-on. An overview of the setup that allows you to work with all these things in a seamless way. We have been dedicating several meetups before this workshop to set up. I know it's really boring. No one really wants to do that. But we got that out of the way. We already have information about how to do it right. And today, hopefully, we're going to practice it. And my argument is going to be that if you bother setting things up right once, then you can work in a very fluid way without worrying about those details any longer. So this document has now here under the demo has a slides link. I don't think you need to click on there because I'm going to present them now. So the idea now is to discuss the entire ecosystem of tools that help you work in data science, including tidyverse, but not exclusively, everything around it. So the key tools that we're going to be working with are, of course, that's what we're here. But then we also use Git for taking pictures of our projects at different points in time. We're going to use GitHub to share those pictures with the world, particularly with other colleagues. And all of those things we are going to do from an interface, which is RStudio. So RStudio sits in the center of all of this, and it's probably the least, it's the tool that many of us use the most, but at the same time, it's the one that does probably the least, because the tool itself, the only thing it's doing is allowing you to talk to these other tools. So RStudio is just a front end, is like the actual box of your car, but then the engine inside it is R, right? In the same way, GitHub is just a website, and the engine of GitHub is Git. So Git and GitHub, of course, just the name suggests the relationship. They are very close to each other, and then R and RStudio are very close to each other, but RStudio extends its interface to also include features that allow you to work with Git and GitHub, because those tools are so central to working with data science. So let's focus for a moment on R. R is an R programming language. It is also a program in your computer that runs other programs, and allows you to do computations, particularly statistical analysis and visualizations in a very efficient way. And this shaded area here refers to what's called base R. So when you install R, it comes with some features in something that is called a package. So a bunch of things, we can call them a package, and the basic package that comes with R is called base R. So a package includes, of course, the programs, which we call in R, we refer to them many times as functions, function 1, function 2, function 3, function 4, and so on. Good morning, Fiona. Hi, very happy to have you here. No problem at all. We are doing an overview of the toolkit. I can probably tell you later if you missed anything, but I don't think you did. It's just an intro. So I'm just overviewing the toolkit. Actually, I need to only back up one slide to keep you on track. So basically, I'm talking about how the different tools of data science relate to each other, how GitHub relates to Git, how R relates to RStudio, and how RStudio is at the center of all these tools and allow you to interface with all of them. So from one single place, you can do things with all these tools that together allow the data scientists to work fluidly. So we were now talking on R specifically, and I was discussing how R comes with some tools, but not a lot. Some comes with a package, which is a collection of things called base R. So the basic package in R is called base R. And right here is where I was. So it includes functions, so things like sum, things like mean, right? Allows you to do computation, but also includes some data sets represented here by these spreadsheet-like figures, and also includes help files. So these three main components are the key components of R packages. But then R is very powerful today, not just because it comes with useful tools by default out of the box, but because it allows people like me to extend the collection of packages that make features available to users. So we can build other packages. So this is package 1, package 2, package 3. So we at 2 Degrees, for example, we build some packages that do specific things, and there are maybe 15,000 packages today that do different things. So the tidyverse, which we are going to be talking about in a moment, is a set of packages. So you can imagine, let's go back one slide. So you can imagine that these packages could be packages in the tidyverse. So the tidyverse is one package itself, but it's also a collection of packages. So when you install the tidyverse, all it does really is call it meta package. All it does is it installs a bunch of other packages. So the tidyverse has a goal, and that goal is to provide tools for data science, which is the focus of this workshop. And it is written in such a way that maybe it is more verbose than other alternatives. Maybe some of the things that you do in the tidyverse may need to type more characters, but those characters are very meaningful. So in your brain, generally, it's much easier to understand concepts like filter, for example, or select. It kind of clicks something in your brain, and then you remember what that is and what it does better than if you have to express the same concept of, for example, picking some rows or subsetting some columns. If you had to express that concept with more terse syntax, like a square bracket. So you can do the same things in R in many ways, and the tidyverse chooses the ways that are closer to human thought. So the idea is that once you internalize these tools, the speed at which you do data science should be the speed of your thinking, right? Your hands in the keyboard should kind of flow and should type fast enough so that it shouldn't be a limitation. You could only be limited by how fast you can think and how fast you can iterate through the task at hand. There are other languages like C++, for example, that require to do the same tasks at the lower level, and I probably the comment that I made before is not the best to support what I'm trying to say right now. So I said that in the tidyverse, you need to type, for example, filters, several characters to subset a data set, a data structure, as opposed to just square bracket. Okay, so filter is more characters than square brackets. But on the other hand, there is other languages that to do something like the entire protocol, the entire algorithm, for example, that the filter function does. Maybe in C++ you need to type even more characters, you need to allocate memory, you need to do a lot of things that are closer to the machine and not so close to the human thought. So basically the tidyverse, and just to wrap this slide up, wrap a lot of internal details that are relevant to computers but not for humans. So the tidyverse is to the left of this slide because it's close to your brain and not so close to the computer. So you saw this image before, except Fiona. So this image captures all the different tasks that involve a data science workflow. Usually we import data, we tidy it to restructure columns and rows, to reshape the data in a way that is then easier to work with, because we then enter a phase where we generally iterate many times until we come out with something to communicate to the world. Many times we need to generally transform our data to produce some summary, to produce some plot, to create some models, some regressions or whatever, and then we understand what's going on and we capture it in a way that is, okay, I'm ready to send a report, right? So that's what this slide is trying to capture. And Fiona, one thing you missed is that the structure of the workshop is so that each lesson, starting from the next one, touches in almost all items of this workflow, so that every lesson in itself is self-contained and is useful. It's just that as we progress throughout the workshop, the tooling will become more complex and the task will become more complex, but that also means that you can jump in or out as you please, and you will always find that any one lesson might be showing something like pretty cool, because it is going to be a data science task in itself. So the tidyverse, as I said before, is a collection of packages, and each of these little hexagons represents a package, and these names are important because that's the kind of thing that you need to Google when you are stuck with something. So you can type, tidyverse, and it will take you to this website here. And then within the tidyverse, you will see all these packages, and you will hear me mention maybe the names of the packages. But sometimes, what you want is an action. You want to say, I want to select something, I want to filter something, I want to, pivot a table. So those names, along with the package name, combined together will be very powerful in letting you Google things. And that's how we learn. So one key idea of the tidyverse, to install any package in R, you do install.packages, and then in this case tidyverse, and you will install all these packages at once. One key component of the tidyverse is this idea. I think that we already covered this. Tidyverse, manipulate modes. Okay, yes. So one key component of the tidyverse is that it uses a consistent data structure that is what's called the data frame, which is basically a spreadsheet. Imagine a spreadsheet with rows and columns, and that data structure is key. Why? Because it is a common interface to your problem. So once the data structure is shaped in that way, all the functions, all the tools that you build to work in data science are aware of that data structure, and then the programs are way simpler to write and way simpler to use. The exceptions are a different data structure that we're going to cover towards the end of the workshop. It's called the list. But the list is actually a generalization of the data frame, or in other words, a data frame internally is no more and no less than a flavor or a special case of a list. So the data frame, to say it again, is very important in the tidyverse, and in particular one kind of data frame that has, let's see if this is the structure, that has this structure where each variable that you care about is a column and each row is an observation. What it means for you depends on your data science problem, and this is formally the definition by the paper that defined this concept, the definition of tidy data. If one variable is a column and one row is a row, one observation is a row, then your data is tidy. If it's not, it's not. This hurts a lot of people's feelings, but to reconciliate this concept with your feelings is that what it is, a variable, depends on your problem. So you define if a variable is the year or is a year plus something else, right? But I'm gonna be showing some examples that illustrate this, make this concrete so you grasp it better. But basically this idea is going to be central because once the data has this shape, the tidyverse provides tools for all the workflow. And if it's not in this shape, you can still work, and I will show one lesson. I'm going to show you how to work with awkward data and how the tidyverse even provides tools for that. But it is just hard, and you need to still do some reshaping when you need to use tools like ggplot2, for example. So RStudio, let's focus on RStudio for a moment, has, as I said before, yes. Until yes, absolutely. So the quick answer is it is not a very important difference, except for the most important difference for you as a user generally is how they print, how much information and what kind of information you see on screen. I'm going to show that in lesson 1 actually, so the one next lesson. And it's generally not super crucial, the difference between data frame and table, and if it is, then discuss it with me because I'm curious. I see there are some differences, but basically a table is a subcase, what's called a subclass of a data frame. So it should have the same properties of a data frame plus a few other things, mostly restrictions that make working with data easier. But if I can hold your attention for until the next session, that would be great. But it is an important question. Actually, I was noticing that I'm reviewing now a package, and I noticed that the author, who is someone as fluid in R as to write a package, he was saying that he never really understood the difference. So that's why I included a slide or an image about the key difference, at least as I perceive it. And there's great documentation about that too in the TiVo or in the blog of the tidyverse. But going back to RStudio, what I wanted to mention is, basically to highlight where on the, so this is RStudio, right? For those who, I think everyone is already familiar with RStudio, but if you don't, this is what it looks like. And the icons here map to the, where in the interface you have, connections to these other tools, and to expose that, okay, yes, it is something that is an interface to every other tool. So there is a whole panel dedicated to R. So R is here where you see console. Then you can just type the same commands I would type otherwise in a plain terminal, where you type R and R starts kind of listening to you, and then if you do 1 plus 1, then it returns 2. So that's R. So R is just a plain vanilla terminal-like program, and runs in what's called a console in RStudio. And then Git, what are the signs that we have about Git? Well, we have this little folder. If you click on the more icon, and if you ask for the hidden files, you will see that there is this folder that starts with a dot, and that is what it makes it to be hidden. So Git is no more and no less than a program that looks for changes in your project and saves snapshots of those changes into a folder called Git. Usually you don't need to know about that, and so much you don't need to know because it's hidden, to make it hidden. But then it's there. So if you remove that folder, the Git disappears. Basically, you remove the tracking feature of your project. And once again, Git, what it does is just keeps track of snapshots of your project, so that you can go back in time and do a lot more other powerful tools. But then, once you have your project and the history of your project captured in that Git folder, you want to share that folder with the world, because your colleagues somewhere else might need, your work to build on that. And how do you send that to the cloud? Okay, you push with this green button, and you send that to GitHub, and then your colleagues from the other side of the world, like me, may pull those changes from GitHub into, again, that little folder, right? And you do that from the comfort of your RStudio interface. Let's move once more. So Rmarkdown is a package, as in the same way that I mentioned that the tidyverse includes a lot of packages. Rmarkdown is special in that it is a friend of the tidyverse, but it's not in the tidyverse itself. That's a distinction that doesn't really matter. But we are going to be using Rmarkdown documents a lot in this workshop, and I hope to motivate you to use them more by showing you some of the features that I think are pretty cool. In particular, there is this one flavor of Rmarkdown document that is called the Github Document. As you can imagine, the prefix of the output format suggests that it has something to do with GitHub. And what it has to do with GitHub is that it renders in a way that is very easy to communicate your data science on GitHub. With very little effort, you can create a web page for your data analysis on GitHub. So that is what this format does. So when you say, give me the output format GitHub document, what you get is a file with a format called MD Markdown, which is the generalization of Rmarkdown. So Rmarkdown is Markdown for R, right? And Markdown is the general way of basically writing plain text in a way that you can express syntax and highlighting and bold and headings. So all those formatting things, you can express them in plain text, as opposed to Word that you would go and click, say, highlight this thing, or make this header 1, or make this bold. But going back to Markdown, so that MD format is very special for GitHub, because GitHub decided that wherever a file has the extension MD, it will try to create a web page for it automatically. So GitHub Document for free gives you a web page on GitHub. You can preview what it's gonna look like here on the viewer pane. So when you click this button knit, and we are gonna do this many times in this workshop, you will get this page here. Let me check the time, because I'm using full screen so I don't see the normal time on my computer. So we're good. So in the viewer, you can preview what the output of running this code will look like once you render it clicking this button knit. So you can see how the word packages is prose, right? It's just text. It continues to be text here. And this line that is in between this weird chunk syntax, the backtick, curly braces, curly braces. So this is what's called a chunk, and whatever you put in there is going to be interpreted as R code. So Rmarkdown will send it to the console internally, will try to run it, and the output of that is going to appear here too. So as you can see, what you write is just plain text, prose or code. And then when you click the button knit, it will actually, whatever you would see on the console otherwise, so if I run this line here, the line 12, on the console I get this thing, right? The output of running that code. So that output goes to an Rmarkdown document. So the Rmarkdown document, what offers you is the ability to intermingle prose and code in the same document. And that is an implementation of a concept that has been developed several years ago that is called Literate Programming. So it's this idea that programmers can express themselves in code but also in prose, and you can explain in prose what you're trying to do and then use code right next to it, as opposed to having a document that has documentation and another document that has the code, or having a document that has primarily code and then you write comments with a special syntax so that that line that you're typing is not interpreted as a command but as a comment, right? And that's fine, but that's ugly to read, as opposed to this other thing that I'm showing you here, that it is just like a web page, right? And it's very reader friendly. So that way you can communicate your data science in a way that a reader without necessarily a lot of experience in the programming language that you're using, they can still understand and follow along, right? So they don't need to be a programmer to read your science. And that's the beauty of data science, because as analysts, maybe your stakeholders won't be our fans, right? So you need to engage them in your discoveries in a way that meets them where they are, basically. So let's talk a little bit about Git. For those who have been attending the DS incubators, you will have seen this image. This image represents, with each of these kind of piles of disks, represent that folder that I mentioned before. So this folder called Git, right, is what's called a Git repository. And it is depicted here with these little piles of disks, right? At the bottom, you can, sorry, when I move my mouse, appears that thing that is annoying. If anyone knows how to, how can I do to move the mouse and not make that appear, that'd be great. So what we have at the bottom is that folder, that .git folder, that Git repository, on my RStudio interface, and in the end, it is no more and no less than just a folder in my computer, right? So that is that's real, that exists there, but then it can be cloned. It can have copies, right? So on the top right of this figure, the one you can see that it's labeled GitHub. So that is happening online. So you can have a clone of your working copy on your own user account, here represented by the name U on the right. And in a situation like the one we are here in 2 Degrees Investing, usually there is what's called an upstream repository, which is the main source of truth. So Alex, I think he painted that very clearly yesterday in another meetup, where there is a central repository, and that's the single source of truth. And there is setups that are simpler than this, that even more clearly communicate that that's the one thing that we all believe is central, right? And everyone else kind of works from there and changes that incrementally, improves that incrementally. But in this setup, that source of truth still is there, right? It is now with the color yellow. So what we do is we create this clone on GitHub that we call fork. It has a special name. And then from there, we create this clone locally into our computers. So at the center of all of this is Git, right? Because these three things, this triangle, what is connecting is three Git repositories. So three of these folders that I showed you before that are called .git and that contain the history or the snapshots of your project. So the arrows represent connections and represent what actions you can do. For example, for my local repository here, I could push to my fork, so my clone on my user account, and I can also pull changes from there. So I can send changes in any direction. And then from the source repository, depending on what's your setup, we are gonna, we discussed that before, but today we're gonna just implement the setups, not discuss it too much. We can, pull changes and life will be fine, because what we want to do is to keep our repository in synchrony with the main source of truth, so that any change that happens on the main source of truth, it is easy for us to pull. So that's what we want to do, to pull from the upstream repository. Upstream is no more and no less than a nickname for this. So we need a name, and someone chose upstream. Imagine a river, and the very source of the thing, the water is coming from upstream. So that's the source of the truth. You pull changes from upstream into your local repository. You are in sync. You have every change that anyone else might have, sent to that source of truth, to that repository. You do your work, and when you're ready, you push your work to GitHub, and then you submit what's called a pull request, which is the vehicle that moves changes from your local repository to first your fork, and then as a proposition to the source of truth. And then someone, a colleague, generally reviews that pull request. That vehicle opens that card that comes with all those snapshots that you are sending to say, hey, I want to update the source of truth with these snapshots. And someone will say, yes, no, do this, do that. And once we all agree, we change the source of truth to include the snapshots that are meaningful, and we might discard others, or they may ask you to do changes. So that is how Git fits in the picture. And as you already know, because you saw it before, RStudio gives you a couple of buttons that allow you to push things to GitHub, and also includes a pane that is called Git to do a bunch of things that allow you to work with Git. Like, for example, create these snapshots that are called commit. Commit is a very special name. It's like saving things in a very powerful way, in a way more powerful way than you save, say, a plain file in a normal folder in your computer. So when all those connections are made, you could get something like this. So you can ask R to give you a situation report, and it will come with a lot of information, from which the very last is the most relevant one. I'm not going to stop here too much, because all of these are details that we can hide, that you don't need to know about this a lot, if you have done the setup that I was advocating for. So I'm gonna help people set up if you haven't done so. And GitHub, let's talk about GitHub a little bit. So GitHub, where does GitHub give you an indication of where the other tools fit in the ecosystem? Okay, so now the same thing now looked from the perspective of GitHub, right? We're still seeing the ecosystem of tools from different perspectives. Now from the perspective of GitHub. So this is what GitHub looks like. It's just a web page or a website, github.com. In our case, we have an organization called 2 Degrees Investing, And today we are going to be working with the repository called tidyverse. So the older state of that repository, now this repository has changed. It has a lot more things, but as to yesterday, for example, it had only a few files. This file called readme.md, remember, is special. Remember I told you that GitHub renders MD files as a website. So if you saw the guts of an MD file, it looks pretty ugly actually. But when you see the file by default on GitHub, it looks like what you see here. As you can see, tidyverse looks like a header, and you also see, oh, holy smokes! I'm gonna leave my mouse quiet. So as you can see, there is like the word tidyverse, ggplot2, tidyr, dplyr, pour are all kind of highlighted with blue. And those are links, so if you click there, you will go to a website. So that's also a feature of GitHub rendering Rmarkdown documents so that they look like a web page. So with this, again, I support my argument that you should be, I'm hoping to motivate you to learn more about GitHub Documents, and I'm hoping to give you in this workshop the tools to make that super easy. Because it is so easy to create a web page for every analysis that you do. If you have in one repository 10 different analyses, and each of those is a single GitHub document, then you can have 10 different web pages that you can send a link to your stakeholders and say, hey, have a look at this analysis, tell me what you think. So Rmarkdown is a very powerful tool for communication, and here's the evidence for that. So what evidence we have of this project being in relation to R? Not much, because GitHub doesn't care about that. But RStudio does leave a record of itself in if you defined this concept of if you formalize or implement this concept of an RStudio project. There is a file called .rproj that defines an RStudio project as such. And that file is the only record that we have here that we have been using RStudio, and in particular R, because we use RStudio to write programs in R mostly, although you can write other languages too. What evidence do we have that this has anything to do with Git? Well, as you can see here on the top right, it says 22 commits. As of yesterday, this repository had 22 commits. Each of those commits is a package of snapshots, or it is a snapshot in itself, sorry. So that is an indication that there is here a hidden folder called .git. We are not seeing it here. It has to be there, otherwise it couldn't be a Git repository. But yeah, that is the indication that this is something to do with Git. So that was the last slide, and it is also the time to make a break. So I meet you here at the top of the hour, and we have a few minutes for general questions, and I'm also going to hang out probably for a couple more minutes to answer kind of one-on-one questions. Do we have, what questions do we have now? Yeah, thank you very much. That was exactly that was a very eloquent explanation. The only thing that gives me like a good standing to mention that that the TIVO is a part of the tidyverse, and the tidyverse is explicitly they acknowledge it is an opinionated way of doing data science. So a TIVO has some the few features that are different from the more general data frame are opinions. So that's because they think some of the things that the general data structure does are ill-advised. So it is not important. I'm not going to get into the details, but I'm just, it is a good opportunity for me to say that the tidyverse is not, it is opinionated, and they acknowledge that. And you may like some of the things and you may dislike them, but at least their opinions are there, and they capture in code what they think is safe or unsafe. I'm gonna put here one bullet point with a link to what's called as cheat sheets. This is mostly for you, Daisy, who show interest in tables. There is a bunch of information there, but probably the one that I recommend is the cheat sheet that says data import cheat sheet. So you will see that cheat sheet in particular has, oops, sorry, this is not the font that I wanted, has like the main differences captured in a very succinct way. And for anything beyond that, yeah, I encourage you to do exactly what Alex said, to kind of reach out in person, because it looks like it might be so few cases that it might be also like not very interesting for other people. Okay, with that, yes, go ahead. I totally agree. Okay, I would like to make a break. It's going to be a little shorter than 10 minutes, unfortunately, but please do relax to go outside if you can, refresh your brain. And the next section, at the top of the hour, we come back here to talk about your setup and help you set up if you haven't done so. Yeah, so see you there.